Selection sort is a different approach. For bubble, you think about you are kind of a bubble, right? Where two bubbles are there, which are basically compared, right? Merged together or blast and then bubbled up, right? This is basically bubbling up. The heaviest one, is it up down, and the lightest one are bubbling up. So with that, you will always remember, and it's very important, to remember there is always confusion between bubble sort, selection sort, what the different approaches are there. So with this, you will be always remember with the name bubble sort, it's basically the heavy one. The goal for this, the heaviest one is to get into the bottom, and the lightest one going to the top, slowly, slowly. The second largest bubble, there is this, and always there are two bubbles are compared. That's why it's a bubble sort. In case of selection sort, it works in a opposite direction. It doesn't work from right to left. It works from left to right. This is also one element is compared with all other element. That's why the time complexity of O of n is square. But it works in the opposite direction, completely opposite to bubble. It means one element is selected at one time. Selection sort, select, right? And the lightest element, the smallest element, keep it at the front by some way and gradually moving towards the right side of it. So you see here the max element we are putting at the end. Here the smallest element, minimum element we are putting into the front. That there is only two way for sorting. Either you put the max element at the end and then move towards it, or put the smallest element at the front and move toward the right. There's only two ways, right, for the sorting, one at a time. So we don't know how this sorting algorithm would work, but from the name definition, right, it should be like whichever is the minimum element here, right? 3. So let's fix the position for 3. Let's have all the elements are in this order. Now, then the second iteration, fix the position for this, and then the smallest one is 4. So 3 we wanted to leave it, 4, then 5, 8, 6, then fix the position for this. This is sorted, then fix the position for this. So it would be 3, 4, 5, 6, and 8. So we are going towards from left to right, keeping minimum element on the left and moving towards it. So if you see, this is in fact from the code wise, it would be in fact similar to, or maybe easier than the bubble sort, where you can choose the position of this. Now here comes the problem solving skills, the concept, how we can do it. Ultimately, we wanted to have, there are 5 position, 1, 2, 3, 4, 5. Ultimately, we wanted to see whichever the smallest element should commit here, and we don't care about all these elements. Smallest element is 3. Similarly, we have fixed this position. Let's leave it. And then from here, we are fixing this position. The smallest element should come here, and we don't care of this. Then this should be 4. Then we go for this, this, and that's how the array will be sorted. Okay. So now we understand what we need to do. Now put some logic here, how we can fix this. Okay. So here the minimum is on the right side of it. We are fixing, going towards it. Let's have one for loop, right? As we clearly see, for every position, let's have one for loop. Let's say as I. Now we are fixing the position of ith. We wanted to have the minimum number here. And then I will become 1 here. We'll put fix it. I become 2, 3, 4. That is one observation. Let's talk about the what all observations we have when we wanted to write a code. So this is one for loop we think, right? This we wanted to have the minimum number. Now second thing come is how we can make sure that here the minimum number would come. The simplest approach, this is another template here, is in this kind of thing, always assume if you are fixing the position for this, that this is the minimum number so far. If you get any minimum number, that would be the minimum so far. So if we are in for loop, like let's say we are in the for loop, I is equal to 0 to n, we in the 0th case, now we can have another for loop where we will see compare all the element out of all this. So first of all, let's assume that ith index, this is a minimum index we have so far. Now let's go to the j. This is the j now. J is 1. Is jth index not the value, right? The value at jth index is lesser than the minimum index. Minimum index is this, right? We assumed the first is always the minimum index. Is this lesser than this? Yes. So now minimum index is this. This is the minimum index. So far, earlier, this was the minimum index. Now, is this value lesser than this? The minimum index value? Jth, this is the jth one, right? This jth one, this is the minimum index m, and this is a I. I is here right now. M is moving, I is constant, M is moving, J is moving under I. Now, this J, is this less than the minimum index? No. Is this, no. So far, we think that the minimum index is this. Whatever loop we are in, I is still pointing to here, right? Swap this value with this value so far. So once we swap it, it become 35846. Now we are here. So we know that this position which we targeted from for I is equals to 0, we have swapped it. It means it is having the minimum value, and let's I move forward, and we will not come back to this ever. Because for this ith position, we assume first that this is a minimum. Let's assume this was 1. If this is 1, this is a minimum one, right? And we have not found any minimum. M is pointing to here. So what we will do is, okay, we will swap I and M. So swapping the same element doesn't make any difference, but we will fix the position for this one and we will move forward. Okay. Now coming back to specific to this example, the position of 3 is fixed. We are on 5. Now here I is, because I is incremented. M, let's initialize M. M is assuming M is always the ith position. This is always the minimum one. Now start the J from here. Now this J, is this minimum, the value of J is less than this? No. This value is less than this? Yes. So let's M equals to J. And then this? No. Next what we will do is we will swap these two elements so that the position of I will be fixed with the minimum value, and now I will move it here. This is how we will keep this array sorted. Now you see, right, base we started with the our approach, thinking approach, and now we are moving towards the code implementation, and we understand this step-by-step approach. It would be very easy to write a code. If you practice some of the problems, it would be very easy for you to write the code if you understand this clearly. Let's start with for I is equals to 0, I less than n is the length of the array, I plus plus. What we are doing? First of all, we are assuming that minimum index is I so far. If we do not get any minimum index, the value of at minimum index, then we will just swap the first itself and then we move forward. If we get any minimum index, we will swap with that any minimum. So we need to find the minimum index in rest of these array value at minimum index. Okay. So now we have to do a kind of a for loop here. For j. Now j we wanted to start with I plus 1. To avoid comparing the same element, we can start with I also. All right. It's just some little justification. Anyways, performance, it's okay for one iteration. J is less than n and j plus plus. Next. Next, we need to see if value at jth index is lesser than the value of minimum index which we have assumed. If value of jth index is less than value at minimum index, then what we need to do, we don't have to swap. We just need to say the minimum index is j. Okay, so we are just pointing, if any value we get, the lesser one, that would be the minimum index. By this for loop, we will get the minimum index, minimum value at this index. I'm calling as minimum index. It could be either I itself, or it could be any other element in the array. But that is for sure, that would be the minimum index. The last thing is we need to do is just do a swap. The fixed position was I. This is what we are fixing it on the for loop, the first, second, third, fourth, and we are swapping it with the minimum index.
Minimum index.
That would happen in some cases where we have the same I value, which is a minimum of this. It's okay. We basically swap the same index. But still, if you wanted to avoid that swapping, we can put one more if condition, if I is not equals to j, to avoid that swap. What I mean here is, uh, it would be difficult for me to move this. Okay, yeah. Just one more condition we can add it here is, if I is not equals to minimum index. But you know that this does not make much difference in algorithm, one iteration. But if someone asks you, right, you can say that to avoid swapping of the same element. Okay. Now let's see the differences between these two algorithms. Anyways, there is a for loop, and inside there is a for loop for every element. We are going to for every zeroth element, we are searching in all the array, rest of the array. Then first element, rest of the array. Second element, rest of the array. So each element is compared with every other element. That's why we have the time complexity of O of n square for both of these algorithms. Actual calculation of the time complexity, space complexity will be clear as when we go. So we will see like every other scenarios, and you will be able to understand a better way. Okay. Now, what are the observations here in terms of the, no, little I would say little advantage over the performance here. Here, can anyone like point out basically what is the advantage of one over the other? So if you see here, right, here every time we are doing a swap between these two elements, the swap is happening here at worst case these many times, swapping, 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 swapping. Then it goes to the end. This multiple swap happen, right? In worst case, 1, 2, 3, 4 swap would happen to fix the position for this. Then to fix the position for this, there would be 3 swap, 2 swap, 1 swap. So there is a n square swap is happening after checking. But if you see here, the swap is happening only for the n times, not n square times. Because here we are not doing the swap. We are just basically, if that value is lesser than this, then we are storing it into a one another variable. We are not actually swapping the elements in the array. We are just keeping the index of the minimum, and we are doing a swap only once. And this would happen for the n times because it's outside the, it is in the outer for loop. That is one advantage for this. And selection, we are selecting one position at a time, keeping it at the minimum one, then selecting second position, keeping minimum at them, going from left to right. The bubble sort, we are going from right to left, bubbling up. This is all like, you keep revising, making a note of it, and remember this.